Hello there, sports fans. Tuesday, you learned how to compute area under a curve the hard way using the limit definition. So today, I promised we'd look at one that's a little bit harder to do. Welcome, and this is Planet Numeracy. My name is Mark Nolde. I've been teaching high school math for almost 25 years now, and that includes my four daughters. But the problem we look at today is going to involve starting at a point that is not zero. So if you're going to have to do a little bit more algebra, but I'm pretty sure you can do it. If you didn't see Tuesday's video, watch to the end for the card in one of the corners here. And I'll also put a description or a link in the description down below. So here's the problem from Tuesday. We want to find the exact area using limits underneath this curve, 27 minus x squared. The last one I showed was 25 minus x squared, but we were doing it across the interval AB. Remember, that's my AB interval. But I knew that A was 0 and B was 5. So it was starting with an A of 0, right? This is what it was. So this formula works wonderfully when you're starting with 0. But when you're not starting with 0, we have to modify it a little bit. And the way that modification is made is like this. Where before my C sub I was just delta x times I, and I substituted it in for x. So it would have been delta xi squared. Now, because I'm starting a little bit further along, I'm starting at the 1. This is my A in the interval AB. So this is going to start a little bit differently. It's going to go C sub I is going to be 1 plus delta x times I. Or the formula, I guess, is A plus delta x times I. So this is what I'm going to substitute in place of this x. So let's go to the next slide and look at that. So now I'm working it out. So we're going to figure out our delta x, which becomes, well, it's b minus a over n, which is 2 minus 1 over n, or 1 over n. So we're going to be using that in this section right here, this section. So remember the last slide we said that my C sub I is now A plus delta xi. So this quantity is what is going to get substituted in here. So let's go ahead and do that. So the area is the limit as n approaches infinity of the summation as I goes from 1 to n of 27 minus x squared. And what is my x going to be? Well, it's from over here. It's going to be 1 plus, and I'm just going to leave delta xi alone for now. I'm going to wait until I substitute all my n's. So that's going to be 1 plus delta xi. And the whole thing is being multiplied by delta x, which is going to be this 1 over n. But like I said, I'm going to wait until I substitute my n's for that. It's just going to make expanding this easier without fractions. So work smart, not hard, right? So again, doing the part my students absolutely love the most. Don't lie, you know you love writing this every single time. Equals 1 to n. Okay. 27 minus this piece here. This is a binomial times a binomial. So it needs to be FOILed. It's 1 plus delta xi times 1 plus delta xi. So first times first, that ends up giving me, whoops, let me put my ink back on here. That ends up being 1, because 1 times 1. Then I'd have outers and inners would be 2 delta x times I. And last times last becomes delta x times I squared. And that whole thing again gets multiplied by delta x. Because remember from before, I didn't write that before. This, oops, wrong color. This is going to end up being the height of each rectangle. And this is going to be the width of each rectangle. Delta x is the width of the rectangles. So when we're making a picture, let me scooch over here. 27 minus x squared. Okay, roughly looks something like this. So we're looking for an area between 1 and 2. So that would be this area here. So I'm building rectangles this way. So this is the height of each rectangle, which is this long piece here, the height. And this is the width, the delta x of each rectangle. So there we go. So let's continue simplifying here. Now remember, there's an invisible 1 here. So that has to be distributed on each one of these terms. So that brings us to the limit as n goes to infinity of the summation xi equals 1 to n of 27 minus 1. Okay, so I have negative 1 times 1. Minus 2 delta x times I, because it's, again, negative of this. And then distribute the negative here. So that becomes minus delta x squared I squared. And the whole thing gets multiplied by delta x. All right, now I think we're safe to go ahead and start to put in our numbers. So this is going to become a 26. But as I get rid of my, whoa, how did I do that? As I get rid of my, I want to get rid of this. So I'm going to start putting n's in for each one of these. So, but remember when there's a constant, I'm going to go back over here. When you had a constant, the sum as I goes from 1 to n of a constant. So my constant's 26, right? So it's like multiplying 26 times, or adding 26 to itself n times. So that just becomes c, the constant, times n. So back over here, I'm going to have limit as n goes to infinity of, this becomes 26n. Okay, notice I'm going to lose this piece here now that I'm putting n's in, because I'm going to evaluate this as n goes to infinity. All right, minus, let's see, 2 delta x was 1 over n, and we got to go back to our summation formulas. So the sum of this, as I goes from 1 to n of I, is n times n plus 1 all over 2. So that's what gets substituted here. So n times n plus 1 all over 2. Minus, okay, delta x is 1 over n squared. The 1 is squared too, but 1 squared is 1, so I don't usually put that in there. And then I squared. And the I squared formula was this. This is in your textbook. I don't typically make students remember this. I just remember it because I've been doing it for a long time. And a lot of times students will end up remembering them too after they have done it enough times. All right, so minus, let's see, I squared. So n times n plus 1 times n plus, no, 2n. 2n plus 1 all over 6. And that is still all being multiplied by the width of each one of these rectangles, 1 times n. So the next thing we have to do is distribute this. So that's getting distributed over here. So I still technically have my limit as n goes to infinity or approaches infinity. And this becomes a 26n over n. And let's see, let's distribute it to this term. So this becomes, let's see, minus 2 n times n plus 1 all over this n times this n becomes all over 2n squared. You can do that. Minus, okay, last term to do this with. We're going to distribute this on this term. So 1, let's see, n squared times n, that's just going to become, I'll write it this way, 1 over n cubed, n times n plus 1 times 2n plus 1 all over 6. Did I mention you're probably not going to do this until the final exam? Yeah. All right, now we're going to go back to limits at infinity. When I had limits at infinity, when I had the same exponent in the numerator and denominator, it evaluated as the ratio of the two leading coefficients. So the leading coefficient in the numerator is 6, and in the denominator it would be 1. 26, I said 6. So that becomes 26. All right, let's look at the next term. This is why I don't have to multiply all this stuff out. I'm just using my knowledge of leading coefficients when n's going to infinity. So I'd have an n squared on the top and an n squared on the bottom. So the leading coefficients, 2n squared and 2n squared, well, the ratio of 2 to 2 is just 1. So minus 1. And then last term, okay, that's this one over here. So n times 2n. So my leading coefficient, if I did multiply all this out, would be 2n cubed. And in the bottom, it's 6n cubed. So we have n cubed in the top and the bottom. So the ratio of the leading coefficients would be 2 to 6, or 1/3. So 26 minus 1, that is 25, and 25 minus 1/3 equals 24 and 2/3. So that would be the exact area, under this curve, this section right here. We're going from 1 to 2. That would be the area under that curve. And when you start to learn how to do this using integrals, you'll get the same answer, 24 and 2/3. So, but anyway, see how I was saying it's not harder. It's just it's got more steps, more moving parts in it, and it is very, very easy to make a mistake with all these negatives and distributing. It can be difficult, but you can do it because you're going to practice, practice, practice. And by the time the final exam comes around, I guarantee you'll hit it out of the park. So that is all for today. All right, I hope you found the content useful for you. Feel free to like, subscribe, comment, share, just to get the word out there. Appreciate it so much. As always, remember, math is not a spectator sport. That's why I always start off with, hello, sports fans. The only way to learn math is to do math.